5.6, logarithmic and exponential equations. So now we're really getting into the meat of solving these logarithmic equations. And we've really got to be pros by now going from logarithmic to exponential form. If not, go back and finish those classwork problems that you have not done yet on changing from log to exponential form. It is going to make everything easier for you. And then additionally, you need to have those properties down. So your notes from 5.5 are going to come in very, very handy because you will need those properties. And if you have them memorized, great. The majority of the ones that we will be using are the power property, the addition property, and the quotient, or the product property and quotient property. And then we will also be canceling some logs. So you're going to see some of the other properties in use here that maybe we didn't use too much in the last example, or last section, excuse me. So here we go. I see one log. Anytime I see one log, we need to move into exponential form. So I'm going to add a note here. Remember, always write in exponential form. This is specifically when there is one log only. That's very important to remember. One log only, you do need to rewrite into exponential form. So 3 is my base, 4 is my exponent, and it equals x. Well, that one was easy. That was a nice way to get started. 3 to the 4th is 81. Now, here's the tricky part. We have to check our solutions. You need to remember from, I don't remember which section it was, but this x here has to be greater than 0. So when I plug in my solution, I need to check if it's greater than 0. And you can use mental math most of the time, but there will be times that mental math is not going to work, or you're going to need to use your calculator or something. So you're just double checking. So this is the checking part. Oh, if I plug 81 in for x, is there any way it's going to be 0 or negative? No, great. Then that's my answer. Now I'm going to move on to B. 1 log. When I see 1 log, I need to think, I'm going to rewrite this into exponential form. Well, wait a second, what's my base? There's nothing here. We need to remember from the last section that when you don't see a base, your base is 10. So my base is 10, my exponent is 1, and it equals x minus 3. This is just 10 equals x minus 3. When I add 3, x equals 13. These are not difficult problems. We are going to be using our basic algebra skills, but we also have to use these properties correctly, or it's not going to matter how good our basic algebra skills are. Now, let's check. If I plug 13 in for x, 13 minus 3 is 10. Not positive, not 0, so we're good. 13 is my answer. Now, let's move on to C. Now, C has 2 logs. So I'm going to have to use a different strategy here. First, I see that I have numbers in front of both of my logs. Therefore, they need to become exponents before you could do anything else. So I have log base 7 of x squared equals log base 7 of 2 cubed. Then I notice something fantastic. I notice that my logs have the same bases, and I have exactly one on the left and exactly one on the right. Therefore, my logs are gone. I can cancel them, and I am left with x squared equals 2 cubed. 2 cubed is 8. So x squared equals 8. How do I get rid of a square? I square root this. So x is going to equal plus or minus. Now I'm going to come over here and do this work. The square root of 8 is 4 times 2, and you can square root 4. So 2 root 2. So plus or minus 2 root 2. But I have to check my solution. and you have to check it into x. And there are two solutions here. I have a positive square root of 8 and I have a negative square root of 8. So I only need to check into the first log because that's the only one with an x. So if I plug in positive square root of 8, that works. If I plug in negative square root of 8, that does not work. The negative will not work. Therefore, x only equals positive 2 root 2. Now, if you do leave it as the square root of 8, I will not mark you wrong, but just beware on a test. The square root of 8 will not be a choice. So be ready for that. All right, moving on. This is some fun stuff here. Okay, I see 2 logs. And they're not separated by an equal sign, so darn, I can't cancel them. And it wouldn't matter anyways because I have a 1, and that 1 would keep me from being able to cancel them. But I see addition. And how can I rewrite addition? Addition can be rewritten with multiplication. So I put the 2 products, the 2 pieces being added, together with multiplication, and they equal 1. Okay, now I am down to 1 log. 1 log gets rewritten into exponential form. So this is 2 is my base. My exponent is what it equals. So 1, x plus 7, x plus 8. 2 equals x squared plus, this is 8x plus 7x. 8 plus 7 is 15. And 7 times 8 is 56. Now, I see that 2 on the other side, and that sucker is going to make my life miserable because I will not be able to subtract that. Factor this unless I move the 2. So I have to move the 2. So 0 equals x squared plus 15x plus 54. Whoa, I forgot the 1. Now I can factor. What multiplies to 54 that will add to 15? 9 and 6. X plus 9, x plus 6. So x equals negative 9 and negative 6. Now, I'm excited. I finished, but I haven't finished because I haven't checked my solution back. I have to check both negative 9 and negative 6 into both of the x's. So I'm going to come back here. Let me change my color so you can see the checking part. So I have to check. Start with negative 9. Negative 9 plus 7 is negative 2. Cannot be negative. So immediately I can eliminate negative 9. It doesn't even matter if it would work in the next one, which it doesn't, but it wouldn't matter. As soon as you get a negative, and if I were to get a positive the first time, you still have to check that second one. Now let's check negative 6. Negative 6 plus 7 is 1. That's good. Positive, and it's not 0. Negative 6 plus 8 is 2. Again, good. It's positive, and it's not 0. So my only solution that works is negative 6. If you don't check, and you give me that both of your solutions work on a quiz, you will have done all that work to only get half credit because you forgot to check. On a test, you would get nothing because you would choose the solution that had both of those as choices. Please be careful. This next one, not too bad here. I see subtraction, which becomes a fraction. So my first number, the x plus 2, is the numerator. X minus 1 is the denominator. And then I see on the right side, I have another subtraction of 2 logs. So I can rewrite them as 1 with a fraction again. X plus 3 is the numerator. X minus 4 is the denominator. Now what's nice here, you have a log of n equals a log of n. So those cancel. X plus 2 over x minus 1 equals x plus 3 over x minus 4. Now I must cross multiply. X plus 2 times x minus 4 equals x minus 1 times x plus 3. So I'm going to multiply this out. I'm going to use mental math. X squared minus 2x minus 8. If you need to work it out, go ahead. X squared plus 2x minus 3. What's nice is the x squareds will now cancel. I'm going to add 2x to this side. That one cancels. So I have negative 8 equals 4x minus 3. If I add 3, I get negative 5. So negative 5 equals 4x divided by 4. And I get negative 1 1/4. Now I need to test that. And you have to test this into every single one of these. Every time you get a positive, you must move on. So if I start in the first one, let me change my color. Let's go with purple. If I plug in negative 1 1/4 and I add 2, that will be positive. So that's good. Now I need to move to the next one. Negative 1 1/4 minus 1. Oh, that one's going to be negative no matter what. This does not work. Since this was my only solution and it did not work, there is no solution. You got to check, you guys. It's very important that you check your solutions. And once we use those properties of logs, you guys, we're using basic advanced algebra skills here. So don't panic. If you're struggling with that, you know where to find me. All right, let's wrap this up. We have just 3 more to do on this one. If x is an exponent and you can't write with the same base, you need to log both sides. So what do I mean by rewrite with the same base? Well, if I look at example A, I have a 4 and I have a 16. Well, 16 is 4 squared. So this is 4 to the x plus 7 equals 4 squared. So I can rewrite them with the same base, which makes your life easier. You can ignore the bases and you're left with x plus 7 equals 2. So x equals negative 5. Now here it doesn't matter if you have a negative or a positive because you did not start with a log. And exponents can be any real number. Okay, your domain is negative infinity to infinity. So it doesn't matter that x is negative. You only need to test if you start with a log. Now, let's say you don't recognize that you can actually rewrite the 16 with the same base and you choose to go ahead and log both sides. I will show you how to do A after I show you how to do B. 3 and 5. You cannot rewrite them with the same base, and I do not want to see you using guess and check here. I want to see you going through the properties of logs. Because I cannot rewrite these with the same base, I just throw a log on both sides. What you do to one side, you can do to the other. In Math 3, we went over how we would actually do this if we were using going into exponential form, going into log form and then solving for x. I'm not going to go that route here. I just want you to jump right into logging both sides. Now I can use the power property, moves the x to the front. X equals, just kidding, not yet. X log of 3 equals the log of 5. Now this is x times the log of 3. So to get rid of the log of 3, to get x by itself, I divide. Now, you should be okay with using your calculator. I'm using my phone, so I have to plug in 5 first. And I can use my calculator because I don't have a base. So I can use the button in my phone, and my scientific, and my graphing, whatever calculator you have. So I have to go 5 log divided by 3 log. And I have to, it equals. And I get 1.46497. The more decimal places, the better off you are going to be. I do not want to see you write this as 1.5. I would not give you full credit for that. So please make sure you are accurate. If you want to write 5 or 6 decimal places, that's fine. Typical is 4. So this would end up being 1.4650 because the 7 would round the 9, the 49 to a 50. So hopefully that makes sense. So I can use the same process back here in A. Now, is it quicker than what I just showed you in A? No, but you can still go through the same process. So you log both sides, and then you move your exponent to the front using the power property. So you have x plus 7, log of 4 equals the log of 16, divide by log of 4, and then you would subtract the 7. So in your calculator, you would do the log of 16 divided by the log of 4, hit equals, and then subtract 7, and you still get the same answer. And then this is a bonus one. I don't know if I have one like this in your notes, so you might want to add this to a post-it note if it's not already in your notes. 5 and 7 cannot be rewritten with the same base, so I log both sides. Use the power property. 3x minus 2, keep it in parentheses, please. Whatever you move to the front, if it's not just a single term, please use parentheses. Now I can divide by the log of 5. I'm very particular when it comes to you guys rounding your decimal places. I would rather you guys keep everything in your calculator. Do not round ever until the end when you are writing your answer. You should never, ever, 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 ever round until you are done. So when I divide this in my calculator, the log of 7 divided by the log of 5. Whoops, sorry guys. The log of 7 divided by the log of 5 is 1.209061955 and a whole bunch of other numbers. I leave that in my calculator, and I know that I'm going to add 2 to both sides. So in my calculator, I just hit add 2 equals. So now I have 3x equals 3.209061955. Now I can divide by 3. So I divide by 3, and I get for x 1.06969. If your decimal is off, and practice using your calculator right now on this one, and I'll have you do it in class again anyways. If your decimal place is off, I will dock points. Your decimal place should not be off. If you end up putting the log base 7 over the log of 5, and let's say you round that to 1.21, because the 9 will round the 0, and that's all you put, you will get a different answer than somebody who uses the entire decimal in their calculator. So don't be lazy. Please be careful. Take your time. Do not rush. And you need to practice these. Without practice, you are not going to understand how to do these. And when it comes time to using the properties on a quiz or test, you will not know what to do. Questions? Come with them tomorrow. Otherwise, you will be able to start your classwork when you get into class tomorrow. See you then.